Oh, there we go. Here we go. It's our tennis people. I don't say it's like, so it's Hannah and Alyssa and Marissa. What do you want to do?
Kaylee said that you guys ditched her. So now she's sitting all alone.
She's crying. Keely's crying in the back of class. Oh. Well, we wish you guys well. We hope that tennis is going amazing. Looks really nice outside. Oh. Okay. All right. Way to go, Alyssa. We love you guys. Way to represent Albert Lee. All right. Let's learn about even and odd functions. Sure. Here's an example of an odd function. Y is equal to x to the third. Can anybody out here guess why we call it an odd function? Because what?
Sorry, you said because I say because the exponent.
Because the exponent is odd. And so one really easy way to determine an even function from an odd function is to look at the exponent. But that's technically not our definition. Here's what makes an odd function. The graph is symmetrical about the origin. And what that means is a 180-degree rotation. So if you were to look at this graph that I have right here, if I were to spin it 180 degrees, would it look the same as it does now? And it would. That makes it an odd function. Now, a lot of people look at it and they're like, well, odd functions, you would just look at the degree, and if the degree is odd, then we're going to call that good enough. Well, it turns out that there's other functions that are odd that don't necessarily have a degree. For example, say y is equal to sine of x. And you don't have to know that, but I'm just, later on this year, you're going to see y equals sine of x, and you're going to understand why it's odd. Turns out, again, it's symmetrical about the origin. So there's a way that we can test to see if something is an odd function. And this is the test that we use. We plug in a negative x instead of a positive x. And what happens is that it produces the function back, but it produces the negative function. Now, a few of you may understand what the heck that's describing. I'll try to describe it just a hair further. Watch. If I plug in a positive value into this cubic, do I get out a positive or a negative? I get out a positive. Everybody agreed? If I would take that same value but plug it in as a negative, would I get out a positive or negative? I get out a negative. So you would get the same value, it would just be negative. And that's what this is saying. If you plug in a negative, you get out the same value, it's just negative. And we'll show you what that looks like here in a little bit. But an even function, anybody think they could give me an example of an even function? Yeah, a parabola is a classic example of an even function. Y is equal to x squared. As you notice, the degree of the equation is even. There's other functions that are also even, such as y is equal to cosine of x. That would be an even function. What makes something even? Even number, and also the fact that it is symmetrical about the y-axis. So does everybody agree I could take that parabola and you could reflect it over the y-axis and it would look the same? That's what makes it even. So odd functions are symmetrical about the origin, whereas even functions are symmetrical about the y-axis. There's a test that we use for that, and it is f of negative x is equal to just f of x. So when you plug in a negative x, it produces the function in its original form. Let me help you understand what that means. If I plug in a positive value, what kind of value do I get out for this? Positive. If I took that same negative value and plugged it in, everybody agree I'd come out with the same output? Yep. All the positives map to all the negatives. They all produce the same value. Okay. If you look at this first function, it is, again, x cubed minus 4x to the 1 power. Does anybody want to guess whether that's going to be a odd function or an even function or neither? It is going to be an odd function. Why do you think it's going to be odd? All of the degrees are odd, and that's what's going to make it an odd function. Now, my dear daughter Tenley, a wonderful little kid, she's 10 years old, and a smart little kid. Does everybody agree that Tenley would be able to determine that that is odd as well? Only Tenley doesn't know pre-calculus, okay? She's in 5th grade. So let's just all admit that we have to do a little bit more to show that this is odd. Simply looking at the exponents, that's not going to cut it. Let's actually go through the process of plugging in negative x. Oh, I just got 3 eye rolls in that process. Okay. Tenley doesn't get credit for the class. You guys do. So I'm going to plug in a negative x, and so I get negative x raised to the 3rd power. And then minus 4 times negative x. For those of you who don't want to use parentheses, that's fine. Just be ready to have it marked wrong on your test when you make mistakes. Okay, take the time and show the work like you should. I'm not doing it just to take extra time. What happens if we take negative x and we cube it? Negative x cubed, very good. And then minus 4 times negative x is going to be plus 4x. Is that the same as what we started with? No, it's the opposite. So if I factor out a negative 1, will that help make it the same? So let's factor out a negative. And when I factor out a negative, I get positive x cubed minus 4x. Is that the same as what I started? It is. So watch this last step. You guys should all have an aha moment in this setting right here. Okay? Does everybody agree that this is the same as that? And this is f of x, right? So therefore, this thing here is negative f of x. So what did you just show? Please look. We wanted to show that f of negative x is negative f of x. And look, f of negative x became negative f of x. You see it? Okay. So, my apologies for how horrible of a job our world has done in helping you appreciate geometry and some of the finer things of this world. But you just did a proof. Okay? And as soon as I say proof, you guys are automatically you guys are automatically conditioned to be like, oh, I hate everything that's proofs because nobody gets it all, which isn't true at all. Like a lot of people do get, they're just scared to say it because they're afraid you're going to make fun of them. But the fact is that you just did a proof, okay? And you liked it until I said the word proof, and then you decided you weren't going to like it. But you said that f of negative x is negative f of x, yes.
Past week, literally, I've been saying, I can feel it. The proofs are coming. I can feel it.
Yeah, and
it was like, no.
it's not. They're very light. I mean, this is a very small proof. There's not much to it. So, let's do the next one. We've got negative x squared plus 10. This is the same as negative x squared plus 10x to the, anybody know the degree on x? It is 0. It's x to the 0 because anything to the 0 is 1. Okay? So that's why it's just written as 10. So, do you think that this is going to be even or odd or neither? It is even because 2 and 0 are classified as even numbers. So let's show that this is even. f of negative x. I plug in the negative x, I get negative x squared plus 10. I'm waiting. I plug in the negative x here, and do I apply the negative first or do I square it first? Square it first, that's the order of operations. So when you square negative x, what do you get? Positive x squared, and then you make it negative. Okay, so again, take negative x and square it, that's positive x squared, and then apply the negative out front, that'll be negative x squared.
Why is there a negative out front?
Because of this negative right here.
So then why is the one
Because I'm plugging in a negative x. So this negative x is going in for that x. So you have negative x squared. That was a point of confusion. Is everybody okay? All right, here we go. And then I have plus 10 on the end. Is that the same as what I started with?
Yes.
So therefore, that is the same as f of x. This is f of x. So look at what we did. We said f of negative x is f of x. They are the same. So this one was an odd function. This one was an even function. That's what we've just shown. I'll do an example where one is neither. I wrote down the wrong problem in the notes. We'll go x to the fourth minus x squared plus x. Sorry about that. We'll change the problem. All right, so what do you notice about the degrees on these exponents? They're not all even.
No, they're not.
We have one that's odd. So you have a mixture, so therefore it's not going to be even, it's not going to be odd, it's going to be neither. Let's show that. So we do f of negative x. So we have negative x, that quantity to the fourth, minus negative x, quantity squared, plus a negative x. What is negative x to the fourth power? X to the fourth. The negative will disappear after you multiply it 4 times, right? So an even number will produce positive, whereas an odd number will produce negative. Next one will be a minus x squared or a plus x squared. Be a minus x squared, because you have negative x squared is x squared and then subtracting. And plus x or minus x? Minus x. Is that the same as what we started with? No. So because it's not the same as what we started with, we know it's not even. Let's try factoring out a negative and seeing if it's the same then. If we factor out a negative, we get negative x to the fourth. We have a plus x squared, and we have a plus x. Is that the same as what we started with? No. So therefore, neither is our option.
You're always going to plug in negative x.
Always plugging in negative x.
Like, you never... Okay.
Always. Both rules start with plugging in a negative x. It's just what we get out. Yes? Okay, please draw these 6 functions. The first one is a parabola, and it's centered at 4, negative 2. The next one is a reciprocal function, and its center is going to be at 2, 1. The next one is an absolute value function, and it is centered at negative 4, 0. No, you could just write down the shapes. Wendy Ombres has a birthday today. You can say happy birthday to Miss Wendy someday. I said happy birthday like 4 times. This one is at 5, 2, and it's a square root function, heads off to the left.
Is that negative 2, 0? The last one?
This one,
No, the one below.
this one right here.
No, the one over right? Yes, that
Yeah, negative 2.
negative 2, 0.
Yep. This is a cubic function. It goes through positive 4. So 4 is at 5, 2. 5 is at negative 4, positive 4, 0. And then 6 is going to be centered at negative 2, 0. Better? Okay, this is our last. Yep, 1 is centered at 4, negative 2. And 2 is centered at 2, 1. 2, 1. Okay, so our goal for this one to finish off is to look back. This is a little bit of a review of our transformations we've done over the past few days. And instead of giving the equation and writing the graph, you're going to be given the graph and you want to come up with the equation. Okay? So just describe for me the shift that's happened here. Right 4 and down 2. So what's it going to look like if it's right 4 and down 2?
Inside
Good, yep. Y equals x minus 4 quantity squared plus minus 2. Yep, excellent. So you can see that the squared tells me my parent function, and then you can see horizontal shift to the right 4 and down 2. So that's what we want to try to accomplish with these examples right here. Some of them are a little bit easier, some are a little bit more difficult. What's the parent function here? 1 over x. Okay, yep, 1 over x. It's your reciprocal function. So 1 over x, but what's the shift? Right 2, up 1. Yep, so 1 over x minus 2, that's going to create the right 2. And then the plus 1 will shift it up 1. That's not too bad, right? I heard my good friend Avery speak about absolute value here. Do you have the answer, Avery? Negative on the outside, how come? Because it's flipped upside down. And if it's shifted to the left 4, what are we going to have? X plus 4. It's a vertical flip. It's a vertical flip, so the negative will sit on the outside.
I get that. Why is 4 inside?
Because it's a horizontal shift.
Oh, yeah.
If it's a vertical shift, then it sits on the outside. Number 4. Yeah, it's a square. See if you can come up with it. This one's tough. I don't think most people get it. You try it. You try it. Just try something. Don't be afraid to try something. Tell you what, I'll give you the exact number of notes you get on the ACT. All right, here we go. So it looks like I've got a square root, right? And everybody looks at it, and hopefully people have a plus 2 on the end. Did you at least get that? Okay, now describe the transformation other than the up 2.
Negative 1 or negative on the outside, right?
Okay, so it's a horizontal flip, right? So if it's a horizontal flip, does the negative go on the inside or the outside? It's going to go on the inside. And what's the shift? To the right 5, right? So it'd be x minus 5. So to be clear, this is one way that you could express your answer. But the other way you could express this, and the way you would more commonly see it, would be y is equal to the square root of. Notice how the 5 will be positive and the x will be negative. These are the two ways that you could express that one. Notice how the x is negative, and that creates the reflection to the left. We all good? Okay, so Ella, just because I see if I can get to where you're going to say there. Notice how I started with this. I said right 5, I said up 2, and I said horizontal flip. And this just becomes then the same as that, where it's 5 minus x instead of the negative there. Better? Okay. All right, next one. What do you think? What's the parent function? X cubed. Okay. Shifted to the right. How many? So it's going to be x minus 4. And then, is it a vertical reflection or is it a horizontal reflection? It's actually either, isn't it? I mean, yeah, it's either one. So there's multiple answers here, but most people just put the negative on the outside. I like to think of it as a vertical reflection before I think of a horizontal reflection. But yep. And so for people who are wondering what I just said, if you take this shape and you flip it vertically, you get this. And if you take that shape and you flip it horizontally, you get the same thing. So with a cubic, it works out that a vertical and a horizontal flip are the same. All right, last one. Oh boy, what's the parent function? 1 over x squared. Excellent, excellent. So we've got y is equal to 1 over, and what's my shift? Left 2. Tim's dancing. You're an excellent dancer, Tim. And so there we go. We've got 1 over x plus 2 quantity squared. Nice, I heard. Excellent. Good job. Way to go.